questions 2-1, 2-3, and 2-4. This is Mr. Sari, and we're starting with some operations involving imaginary numbers, real and complex numbers. Okay, so first thing we do is we are taking 11 minus 3i, we're multiplying, and we are subtracting 2 times the quantity of negative 3 plus 9i. So the first thing I would do here is I'd multiply this negative 2 and distribute that negative 2 into each of these. So negative 2 times negative 3 is positive 6. And negative 2 times positive 9i is minus 18i. So I've got 11 minus 3i plus 6 minus 18i, and we can combine like terms here. The real numbers combine to make 17, and the imaginary numbers combine to make minus 21i. So that leaves us with the complex number 17 minus 21i. And there we go. All right, next we've got a multiplication of two complex numbers. So just like if it were for variables rather than imaginary numbers, we FOIL, as some of you like to say. So negative 7 times 2, that's negative 14. Then negative 7 times 8i, that is negative 56i. All right. Then we have 7i times each of these terms. So 7i times 2 is plus 14i. And then 7 times 8 is positive 56i squared. So positive 56i squared. Now we combine like terms, but remember I squared equals negative 1. And this is because I is equal to the square root of negative 1. So if we were to square both sides, we get I squared equals negative 1. So essentially, you treat I like any variable, except I squared becomes negative 1. Okay, so we've got negative 14. So these two in here, negative 56i and the 14i become minus 42i. And then this negative 14 and this 56i turns into 56 times negative 1. So essentially this is 56 times negative 1, which is just negative 56. So I've got negative 14 minus 42i from those two, minus 56. So I can combine those. So we get negative 70 minus 42i. Now remember, for these answers, for these complex number answers, we always want to express our answer in the form a plus bi. We write the real number first and the imaginary number second in our two-term binomial. All right, moving right along. We have another multiplication now that's squared. When we square it, the temptation is to square each of these, but that would be wrong, because remember that when we square each term, when we square a binomial, really what we have to do is multiply it by itself. So we got negative 3 plus 4i times another negative 3 plus 4i. And then we FOIL. So we take negative 3 and multiply it by the negative 3 and the 4i. So we have positive 9 minus 12i. Then we take our 4i and multiply by each of these. 4 times negative 3 is negative 12i. And 4i times 4i is positive 16i squared. So again, I squared, that becomes negative 1. So that I squared term can become negative 1. So this becomes plus 16 times negative 1, also known as minus 16. So I've got those two negative 12i's can become negative 24i. And then this 9 can combine with this negative 16 to make negative 7. So we have negative 7 minus 24i. Again, notice I am writing it in the form a plus bi for my final answer every time. All right, got another multiplication over here. So we've got 3 times negative 2, it's negative 6. 3 times negative 5, it's negative 15i. Then we've got the 8i times the negative 2, that's negative 16i. And 8i times negative 5i is minus 40i squared. So again, this I squared right here becomes negative 1. This becomes plus 40, because it's negative 40 times negative 1, which is positive 40. This positive 40 combines with this negative 6 to make positive 34. And then those two I terms can combine to be negative 31i. So we have 34 minus 31i is our final answer there. All right, moving right along. Okay, when we're dividing by a complex number or any number with I in it, what we want to do is rationalize the denominator. Same thing you would do if it were like a root 5 or something like that. So remember, what we do is we have to multiply by the conjugate of the top and bottom. So we are multiplying by positive 3 minus 5i. So whenever you're trying to do this, what you're always going to do is keep the first number the same, change the sign of the second number. That's what we multiply by. But we got to do it on top and bottom. So we multiply by 3 minus 5i on top and bottom here. So we've got 45 minus, so again, remember we're distributing. So 15 times 3 is 45. 15 times negative 5i is minus 75i over, and then we distribute this. Remember, the whole point of doing this is that the i's completely cancel out the denominator. So I'm going to show you why and how this happens. So we have 3 times 3, that's 9. You've got also 3 times negative 5i, which is negative 15i. Then you've got 5 times 3, that's plus 15i. You might notice that these two have opposite signs, they'll cancel. Then I've got 5i times negative 5i to negative 25i squared, which turns into negative 25 times negative 1, which is positive 25. Our two negative 15i and positive 15i cancel out to 0. So all I have left is 9 plus 25, which is 34. And there we go. So we can leave our answer just like that. So 45 minus 75i all over 34. Okay, next we have 1 minus I over 3 minus 2i. So again, we're multiplying by the conjugate of our denominator. So we're going to multiply top and bottom by 3 plus 2i over 3 plus 2i. So I'm going to have to distribute top and bottom here since I have a binomial both on the numerator and denominator. Okay, so I can do it for my numerator first. 1 times 3 is 3. 1 times 2i is plus 2i. Then I've got negative I times 3, that's minus 3i. And I've got negative I times 2i, which is negative 2i squared. Okay, we know this will be minus 2 times negative 1, so that'll turn into plus 2. So we can go ahead and make that a plus 2. I'm just going to cross it out. Say plus 2 instead. Okay. So now, up top I can combine like terms. So 3 plus 2, we've got 5. I'm just going to leave this right here. And then 2i minus 3i is minus I. So I got 5 minus I is the final answer for my numerator. Now I got to do the same thing with the denominator. Okay, so I got 3 times 3, that's 9. We've got 3 times 2i, that's 6i. Then 3 times negative 2, that's negative 6i. Again, that's always going to happen if you do this correctly, where these two terms cancel out. I got negative 2i times positive 2i, that's negative 4i squared. So our 6i's cancel. And what we're left with is 9 minus 4i squared. Remember, that's minus 4 times negative 1. It's minus 4 times negative 1, which is plus 4. So I got 9 plus 4, which is 13. So 13 ends up being down here, just like that. So I got 5 minus I all over 13. So there is the answer for number 6. All right, moving on to number 7. So we have negative root 16 plus the square root of negative 64. So remember, whenever we are performing operations with square roots of negative numbers, it's always a great idea to first bring out the I. Because remember, I'll be doing this each time, but the square root of negative 16 can be expressed as the square root of negative 1 times the square root of 16. So that's why it turns into I times the positive root 16. So that's how all of these negative square roots are going to become I times the positive version of that root. So I've got I root 16 plus I root 64. And then I can simplify this. So I've got I times 4 plus I times 8. So that's 4I plus 8I, which is 12I. So 12I, final answer right there. Okay, can do the same thing over here. I've got I root 12 plus I root 108. Okay, and you might be thinking, oh, can't really do much with this, which you're right, but you do have to simplify each radical. So root 12. So let's break this down. So 12, I'm just going to do it out to the side over here. So 12 can be written as 4 times 3, and 4 is a square root, perfect square, so I can write it as root 4 times root 3, which remember is 2 root 3. So I have I times 2 root 3, which I can write as 2I root 3. So I've got 2I root 3 for I root 12. Then I do the same thing with 108. So I've got the square root of 108, which I know is, let's think, 12 times 9. I could do that. So root 12 times root 9. I know this is 3, so that's nice. I've already got that. But then root 12, I can break down into root 4 times root 3, which I know is 2. So I got 2 times root 3 times 3. So I got 2 times 3 is 6, so I got 6 root 3. So root 108 is 6 root 3. So I can say plus I times 6 root 3, which is also known as 6I root 3. So notice how they have a common root. So I've got 2I root 3 plus 6I root 3. Because they have the same root, I can add these and create 8I root 3. So 8I root 3, final answer there. Okay. Next, I've got square roots, or more square roots of negative numbers. So again, we want to simplify this. So that's the square root of 9, which is 3. But since it's negative, it becomes 3I. So we got 2 minus 3I times 5 plus square root of negative 25 will be 5I. Okay, so now we FOIL. So we FOIL, we have 2 times 5 is 10. So 2 times 5 is 10. And 2 times 5 again is 10I. And I've got negative 3 times 5, that's minus 15I. And negative 3 times 5 is negative 15I squared. Okay, so again, that's going to be negative 15 times negative 1, which is positive 15. So 10 plus 15 makes 25. And then the 10I minus 15I. Now again, this may be a little confusing to some of you. Basically, this term became positive 15. Not that I'm adding 15 to both sides or something like that. I'm just changing this term into positive 15. So 10I minus 15I is minus 5I. Got 25 minus 5I is the final answer there. All right, last one of this variation. And we've got 2 minus I root 2, 3 plus I root 8. Now, when we're performing operations, I tend to like to leave this unsimplified, but just end up simplifying it at the end. It does end up making life a little easier when you do this, especially if you're about to do multiplication. Let's go ahead and do our multiplication. So 2 times 3, that's 6. 2 times I root 8 is plus 2I root 8. Then I've got negative I root 2 times 3, so it's negative 3I root 2. And then negative I root 2 times I root 8 is negative I squared root 16. All right. So root 16 I know is 4. So I've got negative 1, which is I squared, times 4. So because it's two negatives, I'll become positive 4. So I still have my minus 3i root 2 here. Now root 8 we know simplifies. So let's go ahead and simplify root 8. That's root 4 times root 2, which is just 2 root 2. So I've got 6 plus 2i times this root 8 becomes 2 root 2. So 2 times 2 makes 4i root 2. So I got 6 plus 4i root 2 minus 3i root 2 plus 4. We're combining like terms with all of these. Notice how these are like terms. 6 plus 4 makes 10. 4i minus 3i is I root 2. So plus I root 2. And there we have it. All right. Using the quadratic formula, this will be provided for you. It is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And remember, that's when you're in the form ax squared plus bx plus c is equal to 0. So that's the only time you can use this formula, when you have it in this form, when you have your quadratic in this form, and you're trying to solve the equation. All right, so quadratic formula. So we got negative b, that would be negative 2, so negative, hate that little thing. So we got negative 2 plus or minus the square root of negative 2 squared minus 4 times a, which is 4, times c, which is 7, all over 2a, so that's 2 times 4. Remember, this is x is equal to this. That's going to be our solution to this equation. So we've got x is equal to 2 plus or minus the square root of 4 minus, so we got 16 times 7, that is 112, all over 8. So I've got 2 plus or minus the square root of negative 108, all over 8. Okay, and I can simplify the square root of negative 108. So we're going to have I root 108, but we can simplify root 108. We can say 12 and 9. So root 12 times root 9. Again, root 9 is 3, so we'll leave that one. Then root 12, I got root 4 times root 3. So I got root 4 times root 3 times root 9, which is 2 root 3 times 3, so 6 root 3. So I've got 6 root 3 is what this ends up being, but don't forget about our I. So we got 2 plus or minus 6i root 3 all over 8. All of these are divisible by 2, so I can go ahead and reduce them all by 2. The way that actually happens, though, is it factors out of the top. 1 plus or minus 3i root 3, if I factor out a 2 out of the top. Then my 2 and 8 can reduce to 1 and 4. So final answer, 1 plus or minus 3i root 3 all over 4. Okay, there we go. So here's our quadratic formula. All right, let's do another one. So we have same formula again. A is 2, b is negative 3, c is 5. So same formula. X is equal to negative b, so that's positive 3 plus or minus the square root of negative 3 squared, that's 9, minus 4 times a, which is 2, times c, which is 5, all over 2 times a, which is 2. We've got 3 plus or minus the square root. 9 minus 40, that's negative 31, all over 4. Always nice to see a prime number inside your radical because you know it won't simplify. But we can bring out the I, so our final answer is 3 plus or minus I root 31 all over 4. Okay, there we go. So there is number 12 using quadratic formula. All right, next we've got determining end behavior. So remember, for determining end behavior, we know every single polynomial is always going to have the same end behavior as one of our 4 basic functions. And by 4 basic functions, I mean x squared, negative x squared, x cubed, or negative x cubed. So one of those four, and it's depending on the highest exponent, which again is called our degree, highest exponent, and that's whether it's even or odd. So it's got to be either even or odd. Notice how these two are even, those two are odd. And also has to do with the coefficient of that term. And whether it's positive or negative. Okay, so for this one, our highest degree term is right here. It's even, so we know we're working with those two. And it is positive, so we know we're working with this one. So if we know what x squared looks like, remember x squared looks like that. So its end behavior is going to be the same as x squared. It's even and positive leading coefficient. So even and positive means it matches the even and positive one of these four. And that rises both ways. So it rises left and right. So it rises both ways. All right, for this same one, number 16, look at my highest degree term. I see that the exponent is odd and the leading coefficient is negative. So I go out of the four of these, I go to the one that's odd and negative. And I remember that the odd and negative one, remember this is positive, it looks like that. So the odd and negative one looks like the opposite of that. So it rises left and falls right. So this one rises left and falls right. Okie dokie. Next, we've got this one. This one is a bit of a trick in the sense that you look at these two terms and they're both squared. So this is not a simplified polynomial. So we have to simplify it first. So it simplifies to negative 4x squared minus 5. And now we can look at our highest degree term now. We see that it is even because it's x squared, and it's negative because the leading coefficient is negative 4. So we look at this one. So it's got to have the same end behavior as negative x squared, which we recall as the upside down parabola. So it falls both ways. So it falls right and left. Okay, finally we have 18, which we look at of all our terms. This one is the highest degree, and we see that it has an odd degree and a positive leading coefficient. So out of odd and positive, we look at our 4 up here, must match the end behavior of this one, and this one falls to the left and rises to the right. So it falls left and rises right. And there we go. All right, zeros now, zeros. So we want to find the zeros for each, determine the multiplicity, and explain what the graph of the function does at each zero, or at each x-intercept. Remember, zeros are the same thing as x-intercepts. Okay, so we've got, first of all, when this is all set up like this in factored form, it's set up for us to find zeros on a silver platter. Because remember, finding zeros means setting the y equal to 0 and solving for x. Well, if I do that, I've got x minus 7 cubed times x plus 4 squared. Well, it's already in factored form. And remember what I do is I set each factor separately equal to 0 when I solve it. So I get x equals 7. But notice, because it's cubed, it means there's 3 of them. So that means there's a multiplicity of 3. Okay, so that is the 0 and the multiplicity. And then explain what the graph of the function does at each 0, whether it bounces or crosses. Remember, it bounces off at even multiplicities, crosses at odd multiplicities. Okay, remember, the multiplicity is not the 0 itself, it's the exponent of that factor. So that's what the multiplicity is. So since this one had an odd multiplicity, we know it would cross. So it crosses the x-axis at that point. So it crosses there. So for this other one, for x plus 4 squared, we set x plus 4 equal to 0 to find the 0 itself. We get x equals negative 4. because it was squared, that's an even multiplicity, so that's a multiplicity of 2. So there's my 0 in the multiplicity. And then because it was an even multiplicity, it bounces off the axis. Sometimes it's described as touching and turning. Essentially what that means, if we were putting this together on a graph, if we had at x equals 7 an odd multiplicity, it means it would cross the axis there. But at x equals -4 here, it would bounce. So maybe it might look like this, where it bounces off and then it crosses there. It might look something like that. Again, we don't have the end behavior of this one, so we don't know, but that's what it might look like from this perspective. Okay. Next, we've got this one, which is not in factored form. So if we want to find the zeros, our first step is to put it in factored form. So factor it. So set it equal to 0 and factor this thing. So what do I see? We see there's an x in every term, so we can factor out an x, leaving us with 1 less x in each term. Okay, now we can further factor this. Hopefully this factors. So we've got 0 equals x times, we're looking for 2 numbers that multiply to 16 but add to -8. And that's x minus 4 and x minus 4, which, because there's 2 of them, I can write as x minus 4 squared. So this is a classic example of one with an even multiplicity. So we'll have an even multiplicity, or a multiplicity of 2, at x equals 4. And again, it's a multiplicity of 2 because of this exponent. Because it's an even multiplicity, we know it's going to bounce there. It's going to bounce off the x-axis. And then for this one, remember, whenever there's just an x out there, it's like x plus 0 or x minus 0. So just x equals 0. And remember, when there is no exponent here, the exponent is implied to be 1. So there's a 1 there. So you can think of it as a multiplicity of 1, but we don't say that because multiplicity implies more than 1. But you can essentially think of that as odd so that it crosses there. And there we go. Okay. So, divide using synthetic division. Okay, so we've got some synthetic division. I'm actually going to break this down to the next. I'll make a second video.